Hey everyone, welcome to another session of CeerazzleDazzle Physics. In today's session, we're going to be talking about ray diagrams for lenses. So before we start, we need to recap about the two different types of lenses. We have a convex lens and we have a concave lens. The convex lens is known as a converging lens. So this one is the convex. So convex. And the diverging one is going to be the concave one. In the converging lens, as rays of light enter it, they focus towards a point. That is going to be the converging lens. In the diverging lens, as the rays of light enter it, they spread out. So that is a diverging lens. Right, if I was to scroll down, we can actually look at a couple of ray diagrams when looking at converging lenses. So, right now we've got an object on the left-hand side, and we've got the converging lens in the center. How do I know that's the converging lens in the center? Well, I know the arrows are pointing away from one another. So therefore, this is a converging lens in the center. Now, your job in the GCSE is to construct ray diagrams for different types of lenses. So the first thing you're going to do is look at the diagram. We've got the F labeled left and right of the lens. There's the letter F. What does that represent? That is the focal distance. That is the focal distance here. And obviously I've got 2f, that is obviously twice the focal distance. We need to use the focal distance when constructing ray diagrams. This part of the course, it's better just to practice and watch me do the whole thing, and then you'll get the general feel of what I'm trying to do. So if you want to construct an image from this object, first of all you have to draw some rays of light. So I'm going to take my ruler, and the first thing I'm going to do is draw a ray of light from the top of the object, passing through the center of the lens and not being deflected at all. So here we go, top of the object, there we go. Wonderful, that's our first ray. Now the second ray is going to go from the top of the object, parallel to the axis, hitting it and then going through F. So it's going to go across, hitting the axis, and now going through F. Wonderful. So we've drawn two rays. Just drawing some arrows here so that we know the direction of the light. So where is the image formed? The image is formed where both those rays of light meet. So the image is formed here. This is the image. The image is formed here. This only occurs when, look at the position of the object. The object is greater than 2f from the lens. So look, the object is greater than 2f from the lens. We get the following setup. So let's talk about the image itself. So make sure you can construct those rays. One going straight through the center of the lens, one going across, then down through f. So it's definitely going through f here. The image itself, let's compare it to the object. Is it bigger or smaller than the object? Well, we can see here the image is smaller. So we have a smaller image. So these are properties of the image now. It's going to be smaller. Is it upright or is it upside down? Well, it's upside down. We'll say it's inverted. And it is a real image. Wonderful. Easy stuff here. Okay, right. So that's the first one we've done. And the position of the object will change in the next diagrams that I show you. So I'm going to move the object in different positions, and we'll watch how the whole diagram changes. So let's scroll down for the next one. It looks very much the same. So the object, what's happened to it? It's now moved in between 2f and f. So look at that. So right now the object was greater than f. Now the object is in between 2f and f. But I still construct the ray diagram with a similar principle. So take my ruler. First ray of light going from the top of the object directly through the center of the lens. Here we go. Let's draw some arrows. Next ray of light going horizontally across. Hitting the lens, now going through F. Okay, so we notice, so I have to extend both of them, I didn't do them enough. Obviously, when you're doing this in GCSE, take your time. There's no rush when you're doing it. Wonderful. So, okay. Right now, we can see that where both of them are meeting up, this is where the image is formed. So I'm going to take a pen and draw you the image. The image is formed right here. So this is the image. So it looks slightly different now. So how has the image changed? Well, first of all, the image is greater than the object. Therefore, the image is much larger. So the image, number one, it's going to be magnified. Yeah, it's still upside down, so therefore it's still inverted. And it is still a real image. Okay, happy with that? So look, similar to the one we did before, but now, because I shifted the object to a different location, I'm getting a different type of image being formed. But I still construct the same rays to work it out. They always, either it's going through straight through the center of the lens, or it's going straight across, then going through F. Right, next one. What about converging lens when the object is less than F from the lens? So I've moved the object closer to the lens, so it's in between F and the lens itself. So let's do the first ray. So O for object, that's the object over here. So now, do the first ray going from the top of the object directly through the center of the lens. Wonderful. There we go. And once again, I'm doing a ray of light going parallel to the axis, then going through F. So I'm going parallel to the axis, then going through F. Wonderful. Right, so what do you notice now? These two rays of light, they're not going to meet. So I can't make these two rays of light meet. The way that I'm going to have to make them meet is by extrapolating the lines backwards. So if I extrapolate the first one backwards, whoops, moving the screen. Here we go. And the other one. Excellent. So now where both of these ones meet, this is where the image is formed. So the image is formed where both of these rays of light meet. Here we go. This is the image. So what's the difference now? Well, we can see that the image is formed on the same side of the lens. Yeah, it's no longer formed on the opposite side, it's formed on the same side of the lens. It's a lot larger now, so this is a lot larger. So let's talk about the image nature. The image nature. Number one, it's a lot larger than the object, so it's magnified. Number two, it's going to be upright. This time it's not upside down, so it's upright. And number three, it's no longer a real image, it'll be a virtual image because I've had to extrapolate the lines backwards. So this is a virtual image. Easy stuff. Right, okay, so we've done three of them now, all for converging lenses, but they look slightly different. The reason why they look different is because I'm moving the object to different locations. So that's the third one, that's the second one, that's the first one, but they're still formed in the same way. It's always hard to remember this one because you've got to extrapolate the lines backwards. Okay, what about a diverging lens? So for a diverging lens, it's slightly different. So we've got the object, it's greater than 2f away. To construct the rays, you still do one going from the top of the object directly through the center of the lens. Here we go, yeah. And there's also a ray of light going horizontally across, hitting the lens and not converging this time, it will be moving away. The reason why? Because it's a diverging lens, so I'm going to move it away. So I'm going to go straight across, hitting it, now moving away. Which angle do I know to deflect it? Well, I'm going to have to match up with the focal point on the same side of the lens. So over here. Wonderful. So you've got the arrows going this way over here. And the reason why I know it's at that angle is because if I extrapolate the line backwards, here we go. Wonderful. So where it meets, so where this line meets the other line, the image is formed in between. So the image is formed right there. So that is the image. Yeah, so that purple, the small one there, this is the image. So the image is there and the object is still the green one over here. So this is for a diverging lens, a little bit harder. So diverging lens, one ray of light going straight through, one going across, then out, extrapolate the line backwards where they both meet, that's where the image is formed. Okay, so let's talk about the image nature now. So this image, for the image First of all, it's going to be smaller, so it'll be diminished. Diminished. Yeah? Everyone happy? Because the object is much larger than the image itself. Next one, it's going to be, is it upright or inverted? This one is upright. And last of all, is it real or virtual? Well, I've had to extrapolate the lines, therefore it's a virtual image. Yeah, quite a lot to take in. Every time I teach this with the kids, what happens is a lot of them, struggle with all the different rays. But once you get your head around it, just do it a couple of times, print out some blank versions of it, and then you can have a go practicing it yourself. Yeah, it's just a bit of repetition to get your mind familiar with it. Yeah. Okay, right, so that's it for today's session. Let's have a quick recap from the top. So diverging, let's go right back to the top. First one, object is greater than 2f. We notice that the image is a bit small when it appears on the opposite side. If I move the object in between f and 2f, the image is much larger, yeah, constructed in the same way. And in the third one, now when the object, look, the green arrow over here, is in between f and the actual lens itself, I've got to extrapolate the lines backwards. Where they meet, that's where the image is formed. And last of all, for the diverging lens, we know that's one ray of light that goes directly through the center of the lens. One goes horizontally across and upwards. If I extrapolate the one deflected down, where it intersects the other ray, I will find the image. And that's it for today's session. I shall see you next time for more cool physics. Goodbye.